So today we're going to take the things we learned yesterday as far as um, quadrant signs and angles around, or reference angles, and we're going to evaluate trig functions around the unit circle. So we're going to use the all-star trig class stuff, and then we want to use that with our reference angle information, and then we're also going to combine that with the special angles. And all of this is going to allow us to evaluate sine, cosine, tangent, and the other three all the way around the unit circle for our special angles. So remember, our 1, 1, radical 2, and our other triangle is the 60, 30 right triangle. That's a 30. So that's 2, 1, radical 3. So we're going to use these three things in combination to evaluate the exact value of some trig functions. So to get started, I'm going to list some steps, and then I have an example to go along with the steps, and this example says find the exact value of the sine of 240 degrees. So now the order of the first two steps really is irrelevant. We just have to make sure we do both of them. So in my first step, I'm going to say find the reference angle, which means we've got to think about where this thing is. And I always recommend you sketch in a tiny graph. 240 degrees is between 180 and 270, so he's down here. This is my angle, which means my reference angle is going to be 240 minus 180. So we do that, and I end up with a reference angle of 60 degrees. That's my special angle that I'm going to use to evaluate the sine of 240. The second thing I have to do is determine the sign, the SIGN. Determine the sign of your final answer, because it depends on what quadrant we're in. Okay, so if I look at this, and this is where we use all-star trig class, or whatever you want to call this, and again I'm in the second quadrant, or I'm in the third quadrant, that's what I meant. And in the third quadrant, only tangent is positive, so that means our answer, when we're done, is going to be negative. If you forget anything, it's this step. For the years that I've taught this, kids always forget to attach the negative sign when you're done. So the third step is just we evaluate it. We evaluate the function at the reference angle, and attach the appropriate sign. So what I'm really evaluating, the sine of 240 is equivalent to negative sine of 60 degrees, because the reference angle is always in the first quadrant, which is always going to be positive. Sometimes we have to make our answer negative. So the sine of 60 degrees, the exact value of the sine of 60 is radical 3 over 2. This is where it's handy to memorize those things, and since it's the third quadrant, we make it negative. We keep our answer exact, meaning we have radicals, the radicals stay radicals, the fractions stay fractions. I don't want any decimals or rounding. So let's try another example for your notes. We want to find the exact value of the cotangent of 495. Well, the first thing we need to do is figure out the reference angle. And to do that, 495, I want to find out the angle that it's coterminal with. So 495 minus 360 ends up being 135 degrees. So now I want the reference angle for 135 degrees. 135 is in the second quadrant, so it's 180 minus 135. And my reference angle is going to be 45 degrees. It's the second quadrant, so to figure out the sign of cotangent, cotangent is going to have the same sign as tangent. So in the second quadrant, that's going to be negative, because only the sine function is positive in the second quadrant. So we are really evaluating negative cotangent of 45 degrees. Well, the tangent and the cotangent of 45 degrees is 1, so our final answer is negative 1. Make sure you attach the appropriate sign. The last thing I want to define in this lesson are what we call quadrantal angles. So they are defined as angles that are going to be coterminal with the coordinate axes. So that's our definition. Quadrantal angles are angles that are coterminal with the coordinate axes. So your x-axis, your y-axis, positive and negative. Examples. In degree measure, we have 0, 90, 180, 270, and 360. So the equivalent radian measure would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are our quadrantal angles. So we also have to memorize the values of our trig functions for these angles because they are really special cases. Before we get started, you want to remember that to do this easily, we want to remember that my x value is the cosine and the y value is the sine, and then tangent can be found by taking y over x. Alright, so we're going to come up with some values for these quadrantal angles. We'll start with 0 degrees as a coordinate. If I am at 0 degrees, I'm sitting on the positive x-axis, so on the unit circle, that would be 1, 0. The cosine of that is the x value, so that means the cosine of 0 degrees is 1. The sine is the y value, so the sine of 0 is 0, and the tangent is y over x, so that's 0 over 1, which is also 0. The next one, 90 degrees. He's completely on the positive y-axis, so his coordinate is 0, 1. The cosine is the x, the sine is the y. Tangent is y over x, so that's 1 over 0, so the tangent of 90 degrees is actually undefined. We can't graph that value. At 180, we're on the negative x-axis, so my coordinate would be negative 1, 0. Cosine, that means cosine is negative 1. Sine is 0. Tangent is 0. It's supposed to be an 80. It looks kind of funny. 270, we are on the negative y-axis, so that's 0, negative 1. Cosine is 0. Sine is negative 1. Tangent, again, is undefined. And then as we go all the way around, 360 is going to be the same as 0 degrees. So that coordinate is 1, 0. The cosine is 1, the sine is 0, and the tangent is 0. So we're going to combine all these things in class and evaluate trig functions at any angle using quadrantal angles, our special triangles, our reference angle, and our quadrant signs.